Hello, welcome back. Now we're looking at what happens when we don't know the population standard deviation. Now this is really common. Uh, it's actually fairly uncommon when you do know the population standard deviation or the sigma. So in the real world, we'll mostly do what we learned today in today's lesson. Now, a long time ago, there was a Guinness brewer, and he was brewing some beer, and he wanted to be really scientific about it. He wanted to get the best beer possible. And so he was doing samples and samples and samples and taking very meticulous notes. And he started to notice that his normal distribution, which let's say a normal distribution looks like this, he started to notice that his values don't follow the normal distribution very well. So what he did is he took it and widened it out and made it flatter. And he did this to the distribution. And he didn't want anybody to know that Guinness is working on this master brew. So he decided to not publish this under Guinness's name or his name. He didn't want to be known, but he wanted it out there in the community. So he called it the student T. So this to this day is called the T distribution. So it's just the normal distribution and it's flattened out. Now he didn't know quite why it was flattened out at the time, but he just knew that it had to be flattened. Now, now we know the reason why it's flatter is because we don't know the population standard deviation. Now there's the difference between t distributions and normal distributions are that they're they're not as tall, the t distribution is shorter, and it allows for more air. Since we don't know the population distribution of um, in our for our normal, uh, the t distribution just accounts for a little bit of error in that value. Now to find our t-distribution, it's going to look almost exactly the same as what we did before. You take your stat minus mean over standard error. But we don't know the sigma of the population. We don't know this, so we have to use the S, which is our sample standard deviation. So our sample standard deviation, we look at our sample, and we just find the standard deviation from that sample. Now, once we have this, we have to deal with this new idea of degrees of freedom. It's an easy idea or a complicated idea, depending on how deep you want to get with it. But for right now, we just have to know that we use a degree of freedom that is one less than the number of values that we have. It'll make more sense, hopefully, when we actually do a problem. Like this. Diet Colas use artificial sweeteners to avoid sugar. These sweeteners gradually lose their sweetness over time. Manufacturers therefore test new colas for loss of sweetness be before marketing them. Trained testers sip the cola along with drinks of standard sweetness and core the cola as a sweetness scale between 1 and 10. The cola is then stored for a month at a high temperature to imitate the effect of 4 months storage at room temperature. Each taster scores the cola again after storage. Our data is the difference between before and after. So this tells us how much sweetness is lost. So to find the t-test statistic, first we have to think about the null hypothesis. The null hypothesis is that the mean is going to be 0. That means there's no difference in the before minus after. There's no loss in sweetness. And our alternative hypothesis depends on um, whether we want it to be, we want to see if there's a loss in sweetness. So we want to see that the difference is more than 0. So that's to test to see if they lost sweetness. So to find the test statistic, we take the the average here. So you go to your calculator, type all of these in, and find the average. I got an x bar of 1.02 with a standard deviation of that to be 1.196. So now what we do is we take our x bar, 1.02, minus a mean of 0, divided by our standard deviation, 1.196, over the square root of n, which here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So over the square root of 10. So I just plugged this into my calculator, and I got 2.696, so it's about 2.7 for my t value. This is my t-test statistic. Now the degree of freedom come in when we're finding probabilities, and that stuff we'll do in the next video.